Okay, so I don't have any formal presentation planned. I was just going to kind of walk through some of the structure of the CDN in the box.
You have to speak louder, please, David. Sorry.
Do you
Okay,
need to dial 15?
a little bit hoarse.
The audio's on. Oh, but never mind.
So, okay, so as I said yesterday, the CDN in the box is in the top level infrastructure CDN in the box. The center part of it is this Docker Compose file, which has each of the different services listed in it. The DB is the Postgres database. I'm not going to go into detail on every one of them. I'm just going to give you an overview of kind of how they work together. We have the Traffic Ops, which is Traffic Ops Go, or Traffic Ops Golang program running independently of the Perl side. And Traffic Ops-Perl is obviously the Perl one. So once we actually do eliminate the Perl part of Traffic Ops, then this container would go away. Traffic Portal, and Traffic Monitor, Traffic Router, Traffic Vault. Then we have a couple of, the TC Cache is actually just an intermediate image built basically just to make it easy to have the edge and mid in common. So they both start off with the same one, install ATS, and get things set up. They just have individual settings in them. Obviously down here we have the origin, which is light HTTP, and just a very simple thing. Then the enroller, which I talked about yesterday, that one I'm going to get into a little bit more deeply than the rest. Then DNS is a DNS server. It's actually running bind 9. And then client down here, probably ought to change that name, but it's actually a SOCKS 5 proxy, which if you have any detailed questions on the DNS and client portions of it, Jeff Bevel in the back there is the person to talk to. He did most of that work. So one other thing to note in the Traffic Ops Compose is the networks. We basically run the entire CDN on a single private network under 172.168.1.16. And every one of the services that we're running, we assigned a static IP under that IP range. So they're all operating on that same one. The individual services have ports exposed to the Docker host, so that you can actually get to them in your browser from curl, directly from your machine. Okay, so stepping through a couple of these, the DB is pretty self-explanatory. I'm not going to go into that, but you can examine the Docker file for that, and should be pretty easy to figure that part out. The Traffic Ops is actually one of the more complex ones. The Docker file for the database is embedded in there, so there's really not a lot to that one. The Docker file installs or builds Traffic Ops. It installs the RPM and goes through all of the machinations of installing all the Perl modules, getting the configuration set up, and see, I've got a number of support scripts to be able to help out in getting all those things set up. Once it's gone through all of that, when you run the container, there's just a run.sh which is common through pretty much all of the containers that we've got running, all of the services. Each one of them has their own particular setup. But one thing I want to point out in pretty much every one of them is something like this while loop. We have one of the big problems we have with Docker Compose. It basically will bring up every one of the services all at once. And if you've set up traffic control by hand, you know that really won't work. You need to have traffic ops in the database running before anything else. And then you need to bring in other components one at a time, have things set up for them. If they all just get started at once, just nothing will run. So there is a lot of synchronization that happens between these things just by using something like this while loop. In this case, it's using one of the PG commands to check the database to see if it's ready to actually take connections. Just checking to see if the port is active using Netcat or Telnet or something like that won't work because Postgres will actually expose that before the database is ready to take connections. So that's one part. Another mechanism that we use for that is down here around line 111, where traffic ops is actually going, once it starts, well, there's Hypnotoad, so that's where traffic ops Perl is actually started. After that, it actually just looks for a file that the enroller creates to make sure that it's ready to go on with the next portion. And that's kind of common between a lot of them. Each one of them has some mechanism to wait on other portions. So another portion is this traffic ops init, which basically goes through, created this function called load data from. It creates, or it looks at this traffic ops data directory, which has a directory for each one of the different data types. So in the case of CDNs, we have the CDN in a box, which just gives the JSON input required to create it. So this is what the enroller uses. The traffic ops container copies these files into a directory that the enroller can access. As soon as the enroller sees that through a FS Notify library that we're using, as soon as it sees a JSON file showing up in one of those directories, it will just pull that JSON in and run it through the Traffic Ops Go client to enroll it into Traffic Ops. So that's the mechanism that we're using for that. And so this directory basically contains static data for the things that we know we can set up ahead of time. The other containers, once they get the containers started up, have all of the network information and whatnot, they will create a JSON file and plop that down into the servers directory. So you can see we have a couple of these already in there, but the traffic ops, traffic monitor, traffic router, none of those have them in here because they're actually generated from the run.sh within that individual service. So any questions so far? Because I'm just kind of...
Yeah, I have a question. So,
Yeah.
Sounds like the enroller is doing two things. It enrolls all the components of traffic control, right, as it builds them.
Yes.
Traffic monitor, traffic router, traffic portal.
Yep.
It also creates like some table time data, right?
Yeah, that's essentially what this traffic ops data is. It's the equivalent of Cabletown data. In fact,
So is there any plans to like split the enroller? It sounds like it's kind of doing two things.
No,
There's
it's
only
not
two
really doing
components?
two things. It's the way that it's doing that second job of enrolling the other servers. It's using exactly the same mechanism. So the servers just write a JSON file into this directory, and it gets done. So it can, the enroller is pretty generic in that way. So, so after going through that, I think probably the other major part to look at is the enroller itself. And it itself is a Go file that's 1,200 lines long. And actually, a lot of that is just dealing with some of the limitations of the Traffic Ops Go client. And so I have a mechanism set up to use FS Notify to watch each one of these directories that that I have listed here. And anytime it sees a new file show up in one of those, it will call the function that it's indicated here. So in the case of enroller type, it's fairly simple. It just decodes the JSON and does calls the create type, which is within the Traffic Ops client. When I pick one that's a little more complex, we'll go to the server one, which does that same thing of decoding the JSON. But one thing that it does here that's beyond what the client code does, if it sees that there is a type named in the JSON file, then it'll go out to the database and look it up by ID, or look up the ID and then insert that. The client code requires the ID to be in there rather than the name. So this makes it much easier to provide static data that references other parts of the other foreign keys by name rather than having to provide the ID.
It's doing that lookup for the ID over the next API. Right?
Say that one more
It's
time.
going over the API. You're not doing SQL calls, are you?
No, it's going through the API.
Yeah.
It's going through the Traffic Ops client
So
code.
the requirement of the chattiness of the API is being encapsulated in this guy.
Yes. So a couple of weeks ago, I suggested, or I put out to the mailing list suggesting that we do the same kind of thing within the Traffic Ops client code. And I have taken this same setup and put that into the Traffic Ops client code. I have a PR that I'm just about ready to submit for that. But it will allow any Traffic Ops Go client to use this mechanism to insert the data. It'll still work with the IDs as it does now. This is just an extra convenience to be able to provide data into it without having to deal with all the IDs. So we do the same thing here with the type, the profile, the status, CDN name, cache group, his location. So the server and delivery services are the most complex parts of this, just because of this kind of handling. What's that?
It's the N+1 problem.
Yes, exactly. So, and let me show this. So another part of this, just to make that code cleaner, I created a function that wraps that functionality. It actually calls the client code and deals with errors, just returns the ID. But so this does cause an extra database lookup, but it does make it a heck of a lot easier to come up with test data. But all of these get funcs that are listed in here will be, those are actually, that's what I've taken and put into the traffic ops client code. So that will actually reduce this by, let me see. Here we go, 213. So it'll decrease the code by about roughly 200 lines. If we go back to the server, as well as all of the code that does this, all of these lines, if that is embedded in the traffic ops client, then all of this section can go away as well. So it's going to reduce this file by quite a bit. Let's see. So the main thing that the enroller itself needs is some environment variables. This TO URL, TO user, and TO password are just what it needs to be able to connect as the administrator into traffic ops, so that it has privileges to insert all of that data. And once the full process is done, so that the enroller doesn't have anything else to do, that container can be killed off, so that there's not an open slot for other things to be able to get into the traffic ops server. Yeah, go ahead.
So how do you get the admin user bootstrap so that you can access it?
Good question. I don't have a plant in the audience. Thanks for the reminder. So this is another part of it. This variables.env at the top level, it's right alongside of the Docker Compose YAML file. Contains settings for environment variables, which there are a lot of them, but we need to have access to the database. We need to have names for each of the hosts. We need to have a login for traffic monitor, traffic vault, traffic router. So those things are all set up within this file. There probably would be a better way to do this, but just to get this going, this is what we decided to do. Also has all of the information needed for creating certs, which that's another portion that Jeff Bevel back here did. There is a service that goes through and generates a cert and ties that in common between all of the different services. That's pretty much correct, isn't it, Jeff?
Yeah, it creates a CD serve.
Can't hear you.
And all the containers trust that CD serve so that everything can talk together and have full SSL TLS validation. Because it doesn't really do much good if you're using this in a testing scenario and everything's invalid as far as SSL validation goes.
Okay. So one other thing that I wanted to point out is, where to go now? There is a make file at the top level of this directory, which the way we have this set up, when the images are all created, it takes an RPM file from basically just looks in the directory of that particular thing. So the traffic ops, there will be, if you put in a traffic ops.rpm file in that directory, then as it starts up, it'll load that and use it as its base. This make file makes it easier to actually do the build. So using the package script, the PKG script, will build all of the RPMs and then copy them all in the appropriate location. And this was something that Brennan came up with. And by the way, Brennan, I did make a change to this to make it work on my Mac, because I do have an RPM executable. So it did find it, but then it thinks it's a Linux machine. So that, I did put out a PR yesterday to fix a few problems. That's one of the things I fixed. So it actually looks to see if if it's a Linux machine first, then it looks to see if it has RPM, and then it follows that pattern. But if you just run make from the top level of the CDN in a box directory, then the RPMs will all be put in the right place, and then you can do the Docker Compose build to be able to do the rest of it. You saw, so I ran through all of the, actually running it yesterday. I don't think it's necessary for me to do that again, but I don't know what other parts I should actually show you, so if there are questions. Oh, I did think of another one. toaccess.sh is a script. It's actually a set of functions that I came up with to be able to get the correct cookie for traffic ops, given login information, and do repeated commands: to get, to put, to post, and that made it a lot more convenient to create the other scripts. They all depend on this. I even created a TO ping, which just goes out and does the unauthenticated ping, and that's one of the mechanisms we use to just waiting for traffic ops to be accessible. That's what the enroller actually uses this. It waits for traffic ops to be accessible before it attempts to connect to it. John.
And I use this in my development as well. I can source this file and I get all these functions in the shell.
So something you might want to look into, because I had a very similar issue with containers having to be up and down in particular orders and be in certain states. If you look at the Lightning Talk repo that I showed yesterday, the PR, in the Docker file itself, or in the Docker Compose file, there's a mechanism you can use to say, please wait to spawn these systems until you meet this criteria.
Is it that wait for container, or
there is
something similar?
a kind of a, it's not really wait for, it depends on, but you can either say it must be ready or it must be healthy, and you get to define what healthy means. So
Okay.
like in my case, I specifically use the same PG is ready to know, is my database alive, and it won't spawn the other containers that
Yeah.
require that.
Yes, I
until,
definitely want to look at that.
Okay.
I'll talk to you later.
That might help you.
But I also want to point out something that happened with the history of this was the original thought was to bridge the gap between Docker and the container suite. But as we approached the deadline and started running into all these race conditions with the containers, the enroller sort of took on a life of its own to sort of be more than what it should be. So a lot of the work's going to be from here on forward is refactoring that out so that we might have this orchestration container, that sort of sits on the side, and it's not like a full-blown orchestration, but just a coordinator, if you will, between the sequence of the containers as they come up. And that would actually probably be a good feature to incorporate there.
What else are we doing with all of our apps?
Hey, Rob, can you speak up? I can't.
I was going to say, it wouldn't be a bad idea to go over all of our applications and traffic control, TC, the monitor, because right now they have this specific list of order that you have to deploy them in, which is what causes pain for this, and sometimes maybe that's even a circular order. Maybe we should look into making all of our applications start up and keep trying to reach the
That was a lot of the challenges
Yes.
we ran into. We had to build a lot of band-aids because the deficiencies of, for instance, traffic routers, that traffic monitor's not down. Just all the dance of getting all these up in the right order.
But
So each component should be able to run on its own until this dependency comes up.
But that's actually a failure mode condition then should be figured out because you
Yeah,
can
those are,
assume
we've already
any
created
component-
issues and bugs for this.
Or it is a complex problem. You need to log and log errors if it's been up for so long. It's not trivial, but
Yeah, certainly something to look at though, yeah. For no other questions, I don't have anything.
Dan,
Yeah.
I have an addition to add to this project, and that's the DNS stuff. Right now, there's just a single bind 9 container with static
Right.
keys for both IPv4, IPv6, C, so everything's hard coded. No files hard coded, everything's hard coded just because of time limits. But very soon it's going to be hard to replace that with a very lightweight final DNS instance that makes DNS and IPs and containers everything dynamic with the exception of one container, which is obviously the DNS container itself.
Right.
So look at that soon in the next couple of weeks.
Yep.
It makes this a lot more scalable.
Yeah, and if you're not familiar with Vinyl DNS, it's actually a Comcast project that was recently open sourced. It used to be called Dennis internally. They rebranded it to Vinyl DNS and put it out as open source. So I think it's vinyldns.io, I think is the site for it. And Jeff has been doing some experimenting with it and talking with the developers, so.
But it is the DNS that we use throughout all of them.
Yes. And it's very much a self-service type of thing. Okay, any other questions? Hopefully this was helpful.